All right, let's talk about something that many of us use every single day, but maybe don't fully understand: the Virtual Private Network, or VPN. We're going to break down what it is, how it actually works, and, this is the big one, how to use it without accidentally opening up a whole new set of security problems.
Think about the last time you were at a coffee shop, an airport, maybe a hotel. You probably hopped on the free public Wi-Fi, right? I mean, we all do. But here's a thought. Did you ever stop and wonder who else might be on that same network with you and what they might be able to see?
Well, the reality is, public Wi-Fi is what we call an untrusted network. Using it is kind of like trying to have a super private conversation out loud in the middle of a crowded room. Anyone can listen in. Your data is just out there exposed to risks like eavesdropping, which is just a fancy word for someone spying on your traffic, or tampering, where they can actually change it. Not good.
But what if you could build your own private, soundproof hallway right through that crowded room? A personal tunnel just for your data? Well, that is exactly where the VPN comes in. It's the solution to this whole problem, a really critical piece of security for protecting your information.
So, at its heart, a VPN is simply a tool that creates that private tunnel for your data, even when you're on a public network. Its entire job is to guarantee three things. First, confidentiality, which means nobody can read your data. Second, integrity, making sure no one can change it. And third, authenticity, which ensures you're talking to the real website you think you are and not some fake.
Okay, so how does this digital shield actually pull this off? Well, it really comes down to three core functions that have to work together perfectly to keep you safe.
First up is what's called traffic tunneling. And this is where that whole tunnel idea really makes sense. Your data gets wrapped up inside another data packet. It's like putting a secret letter inside a sealed envelope, and then putting that envelope inside a plain, unmarked box. Anyone on the outside can see the box, but they have absolutely no idea what's inside. Your data is totally hidden.
Next up, you can't have a secure tunnel without a guard at the gate, right? That's authentication. Before your connection can even be made, the VPN has to check your ID to make sure you are who you say you are. This usually means a password plus a second factor, like a code from your phone, to make absolutely sure only authorized people are getting in.
And finally, we have encryption. Now, if tunneling is the armored truck carrying your data, encryption is the unbreakable lockbox inside it. A VPN uses powerful algorithms to scramble your data into unreadable code. So even if someone managed to hijack your connection, all they'd see is a bunch of useless gibberish.
Of course, you've probably figured this out, but not all VPNs are created equal. There are different types or protocols, and each one is basically designed for a different kind of mission.
So here's a quick look at the three main types you're likely to see. First, there's IPsec. Think of this as the industrial-strength workhorse. It's often used to connect entire corporate offices to each other. Then you have SSL/TLS. This is probably what most of us use when we work from home, since it's built right into web browsers, which makes it super accessible. And then there's the new kid on the block, WireGuard. It's modern, simple, and incredibly fast, which makes it perfect for mobile devices and cloud stuff.
Okay, so VPNs sound pretty amazing, right? A perfect solution. But, and this is a really big but, here's where our story takes a turn. A VPN is only as strong as it's configured, and it is absolutely not a bulletproof solution.
In fact, if you remember just one thing from all of this, let it be this. A VPN is not a silver bullet. The belief that you can just switch one on and become invincible online is a dangerous, dangerous mistake. Every VPN has vulnerabilities that can be exploited.
So how can a VPN fail? Well, there are a few common ways. Stolen credentials, of course, misconfigured network routing. But you know, one of the biggest and most misunderstood risks actually comes from a common feature called split tunneling.
So, what is split tunneling? It's really a feature that was born out of convenience. It lets some of your traffic, like your work stuff, go through the secure VPN, while other traffic, like your Netflix stream, goes directly to the internet. The problem? You've just created an unprotected bridge from the public internet straight into your private network, completely bypassing all of the VPN's defenses.
So knowing these risks, how do we fight back? How do we make sure our tunnel doesn't collapse? Well, the good news is there are some very clear, very actionable steps you can take to fortify your connection.
Here are 4 essential best practices. 1. Always use multi-factor authentication. A password alone just isn't enough anymore. 2. Restrict access. Only give people the bare minimum permissions they need to do their job. 3.
For maximum security, route all your traffic through the VPN. Just avoid split tunneling if you can. And 4, keep your software updated so you're always using the latest, most secure encryption protocols out there.
And all of this brings us to one final critical question. A question I want you to think about next time you connect. Is your VPN, or maybe your company's VPN, configured for maximum security, or has it been weakened just for the sake of convenience? The answer to that could make all the difference. Thanks for watching.